We want to find the derivative of sine. What is the derivative of sine? That's the big idea today. The limit. As h approaches 0 of f of x plus h minus f of x all over h. This is the rule that we use in order to determine derivatives. And I want to find the derivative of sine. So I'm going to write this as the limit as h goes to 0 of what? Sine of x plus h minus sine of x all over h. Cool. Just got to get the h's to cancel, right? How? You know, a lot of times people think of crazy things. They think of like sine of x over n. You know, they think you divide that off, you get 6, right? Like, we don't want to fall into crazy mathematics like that. Yes, Grant? Oh, conjugation. Cool. That's an awesome idea. Awesome idea. Unfortunately, that does not produce anything helpful for us. But I'll give you a hint. It has something to do with trig. Some formulas. Remember, the sine of a plus or minus b was equal to the sine of a times the cosine of b plus or minus the sine of b times the cosine of a. Remember that from chapter 7 last year, right? Nobody asked you. So let's expand this sum of two angles. We have the limit as h goes to 0 of, what would sine of x plus h become? Sine of x times h plus sine of h cosine of x minus sine of x all over h. Huh. Interesting. What do I do? What do I do? What do I do? Who knows? Kind of. That's what we're going to do actually a little bit. I'm going to break it up into two expressions at this point. I'm going to limit as h goes to 0 of, I'm going to write that section, okay? I'm going to write that as the cosine of x times the sine of h over h. Right. Okay. And then plus sine of x cosine of h minus sine of x all over h. So that's the red portion. I just broke it up into two different fractions. Okay. And now we're going to do Katie's idea, which is we're going to factor a sine of x out of that second expression to get the limit as h goes to 0 of cosine of x times the sine of h over h plus the sine of x times the cosine of h minus 1 over h. Looks good, huh? Let's look at what we even have. Try to understand it. What is this garbage that we've got? Okay. Well, if we knew what sine of h over h was, like let's say it ended up to be 1 or 2 or 5 or pi or something, that would help. Like what is the limit as h goes 0 sine of h over h? If you plug in 0, what's the sine of 0? 0 divided by 0. We don't know what 0 divided by 0 is, right? So like if we could determine that, that would be really cool. And then like cosine of h minus 1, what's the cosine of 0? 1 minus 1 over 0. So you can see in both these situations we get 0 over 0. If we could somehow understand this green limit and this red limit, then we would be in good shape to finally know the derivative of sine. But we don't know them. And although I could draw the proof this far, I would be stuck. I would sit and I would look at it and I would say, I don't know what to do. I would be able to go to my calculator and I'd be able to determine what this limit was, but I wouldn't be able to come up with a logical argument. And this is where it really becomes just true genius. You're going to love this, okay? And we need to make a drawing. And our drawing is going to involve some triangles. So over here, we need to draw a picture. I didn't say anything mean. Oh, yeah. Oh, yeah? Really? This is taking a lot. I mean, you know, so yeah, exactly. I think that I've held up to my bargain. Braden, Jake, would you? Okay, all right. So he broke the rule before I did. No, no, no. I think everybody here is my witness that I have been showing genuine restraint, and you crossed the line. That was day one. Like now it's on, and you broke it because when you said I bet you had more hair, I was gonna say yeah, and I had students who were actually smart. Okay, all right. So so you want to roll, dude? I'm ready. We go all day long with this. But they all know who's directed towards. So okay, all right. Yeah, it's on the video. I'm gonna get called in for the world's worst teacher. Well, you're gonna go on like MSNBC News tonight, and they're gonna be like, latest teacher, hammering students in the classroom on videos, talking about how stupid they are. How does he keep his job? Like that's just normal day for us. Um, did you see the? Did you hear about Zach Luther's friend yesterday? He, yeah. So Mr. Luther, his friend put out a notice saying, Um, if everybody in the community could please rake the acorns off their sidewalks, it's very insensitive to the barefoot running community. It's causing a lot of hazards. This is something the barefoot running community should not have to put up, which is acorns on sidewalk. And people and he threw it out there as though he was baiting people. And people thought he was serious. So people just attacked him on Twitter, like thousands and thousands and thousands of responses. So much so that yesterday when I was headed home, I was listening to the radio. I was listening to K-Fan, if anybody ever listens to K-Fan. And Barrero says, and coming up next, we have Barefoot Acorn Running Man. Yep. Believe it or not, we got him in studio. And so, anyway, kind of blew up. So, yeah. So sometimes maybe my videos are just baiting people to see if I could get a reaction. What's that? The kid who was posting online now, it's very insensitive of people to leave their acorns around. It's just not nice. So yeah, so he posted on like Twitter. Yeah, so then he ended up they brought him in the studio and I didn't listen to it. I had to get going, but I'm sure he talked about how it was just a farce. Yeah, so yeah. Okay. All right, chicken boy. Yeah, deer crossing signs. So was she being serious? Okay, so she wasn't trying to pull a farce. Okay, so YouTube Nation people were calling in. They saw the deer crossing signs and crazy deer crossing lady. Okay, so she actually thought that the deer were supposed to know to cross there. Okay. Okay. All right. Sorry, YouTube Nation. Got a little went a little bit below the line there. Okay, so I don't know. This is yeah, I don't. Jake, you're gonna have to think about exactly what that punishment is. I think you were the kind of the referee in this situation. Oh, all right. What is this? Oh my gosh. Oh my goodness. Wow. All right. Here we go. So I'm going to add in here H, and I'm going to add in here 1. Okay? And so the length of AC is 1, and the length of AD is 1 as well. And we're going to call the angle H. We're going to call the angle H. All right? Everybody good with that? I'm sorry. I mess this up every stinking time. This piece right here. Right there. That's 1. So the idea is that, and it's very tough to draw this to be really accurate, but if you were to take, if you were to say that A was like the center of a circle and extended all the way out to C, and you started to swing that radius, it would create an arc. And so you could see that blue part kind of creates a sector there. So that's 1. Now you say, well, Mr. Gens, that doesn't look like it's really proportional or scaled. It isn't, but it's very difficult to draw it so that it is. We would need a little bit more space. So, okay, all right. So here we go. I need to say something that is significant about H and some of these lengths, some of these sides, so on and so forth. Okay. And in particular, what I want to talk about is I want to talk about a few shapes. And the first shape that I want to talk about is a triangle, namely the triangle ACE. Does everybody see triangle ACE? Is everybody good there? Okay, so I want to talk about the area of triangle ACE. The area of a triangle is 1/2 times the base times the height, correct? So I have 1/2 times the base. What's the base of ACE? 1 times the height. Now, in order to determine the height, I'm going to look at segment BE. Would everybody agree that that's the height of ACE? Okay, well, it's hard to do that, but if I recognize that the angle is H, I can come up with this opposite side right over here. In fact, do you know what trig function has to do with its opposite side and its hypotenuse? Sine. In fact, we would say that the sine of H would be equal to the opposite side, which is EB, right? And what is the hypotenuse? 1. So in other words, sine of H is the same as EB, isn't it? So this is sine of H, which means that I can take this guy times the sine of H. So that's the expression for the area of the first triangle. Okay? Everybody good? All right. We're going to talk, yes. Oh, yes, yes. This is just, we're just having fun today. Okay. Area 2, the second area that I would like to talk about is a sector, okay? And that would be sector ACE. Now, if you remember, a sector is a slice of a circle. Can everybody see the sector portion that I have? Okay, so I've got that sector. And do you remember how we determine the area of a sector? Okay, very good. Area of a sector is 1/2 r squared theta. That's the formula that we determined before. Okay. So I'm going to have 1/2 times what is the radius of the sector? 1. Square that times what is theta? What is the angle measure? It is h. Good. Everybody with me there? All right, then we're going to talk about one more area, and we're going to talk about triangle ACD. Triangle ACD. If we look at triangle ACD, again, we could say that the area is going to be 1/2 times the base. What's the base? 1. And now we have to come up with the height. Now, it's a little bit different here. If you look at AD, that length is not 1, is it? But the height would be this opposite side, or CD. Is there a trig function that we know that deals with the opposite side and the adjacent side? Tangent. In fact, we would state that the tangent of H is equal to the opposite side, DC, divided by 1. Or rather, that DC is equal to the tangent of H. And so I have tangent of H. Okay. That's the most challenging part. You guys got through that? Then let's make work of it. Thank you for asking. This is my triangle right there. BE is the height. Better? Okay. How does the area of the red triangle compare to the area of the sector? They're close. Which one's bigger? So would you agree that I could put the inequality sign like that? How does the area of the sector compare to the area of the bigger triangle? A little bit smaller, so you agree I can put the inequality sign like such? All of a sudden, I have a nice handy-dandy equation going on here that is going to help me out a heck of a lot. In fact, I have 1/2 sine of h is less than 1/2 h, which is less than tangent of h. 1/2 tangent of h. Am I allowed to multiply an inequality through by 2? I sure am. And if I do that, I get the sine of h is less than h, which is less than tangent of h. I multiplied through by 2. Now, if you look, I want to come up with something interesting that says something regarding sine of h over h. I've got a sine and I've got an h, right? Now, I got two options. I could either divide through by h, or I could divide through by sine. If I divide through by h, I'll get an h in the denominator, won't I? If I divide through by sine, I'll get a sine in the denominator here, won't I? Now, it would seem that you would want to divide through by h, but the deal is that we want the sine of h and the h to be in the middle. And you'll see why in just a second. So I'm going to divide through by sine of h. What's the sine of h over h? 1 is less than h over sine of h, which is less than, what's tangent divided by sine? How'd you get that, Zeno? Tangent of h over sine of h, Zane says, is sine of h over cosine of h divided by sine of h over 1. He's going to multiply by the reciprocal. And what does he get? 1 over cosine, or secant. So you're very close, Zane. We appreciate you speaking forward. Nope. Good thought, but definitely not. Yes. So tangent divided by sine. I've got sine over cosine is tangent. Sine is sine over 1. I'm going to multiply by the reciprocal. 1 over cosine is secant. Now, I'm going to do one last thing. I would like it to be sine of h over h as opposed to h over sine of h. So I'm going to take the reciprocal of everything. Okay? Now, watch what happens when you take the reciprocal. Okay? So if I have, say, how does 2 compare to 3? Which way does the sign go? 2 is less than 3. Take the reciprocal. I got 1/2. I got 1/3. Now, which way does the sign go? So when you take the reciprocal, you need to flip signs. So in this situation, I'm going to take the reciprocal. What's the reciprocal of 1? 1 is greater than the sine of h over h, which is greater than, what's the reciprocal of secant? Cosine. So here's what I know. I don't know the limit as h goes to 0 of sine of h over h. I don't know that. But I do know it sits between cosine of h and it sits between 1. That's what I do know. And that brings up something extremely important. Something that we talk about regarding the sandwich theorem. The sandwich theorem says this. I'm not going to spell it all out, but I'll spell part of it out, okay? Suppose we have a function that's always on the top. We'll say that that's f of x. And suppose that we have a function that is always on the bottom. We'll call that g of x. And suppose we have one more function that always sits in the middle of those two functions. We'll call that h of x. Everybody okay with the picture? If the limit of f of x as x approaches a is the same as the limit of f of x as x approaches, if the limit of f is the same as the limit of g, what could you say about h? Yeah, if f and g kind of collapse on top on one another, and h is always in the middle, then h must be the same at that spot as well, right? See why they call it the sandwich theorem? Yeah, because it looks like a sandwich. Right, I'm hungry right now. Okay, all right, yeah, exactly. It starts to collapse together. Well, look at what we have. Which function is on top? Which function is on the bottom? Which function is in the middle? Let's let the limit as h goes to 0. What's the limit as h goes to 0 of 1? 1. What is the limit as h goes to 0 of cosine of h? 1, because the cosine of 0 is. So if this is 1 and this is 1, then this must be 1. What did you just do? You just did this right here. You showed that the green part was 1. We were able to just get rid of the green part. Again, we're gonna let h go to 0. If you let h go to 0, what's the limit of 1? 1. We're gonna let h go to 0 of cosine of h. What's the cosine of 0? 1. Well, if sine of h over h is always between those two, then it must also be 1. We can't, because you would get sine of 0, which is divided by 0, which is we don't know. That's what we're trying to figure out. We don't know what sine of h over h is if h is 0. We have no idea. But we know it sits between 1, and we know it sits between 1. So therefore, it must be 1. When it gets to 0, they become equal to each other. Because look at the expression where it came from. If h goes to 0, what happens to the shapes? They all collapse and the area goes to nothing, right? So that's the one spot at which they're the same, but the limit ends up being 1. So look at, we just answered the green. Isn't that exciting? Now we have to do the red. The good news is the red is super, super quick. Yeah, here's a limit that you need to know. The limit as h goes to 0 of sine of h over h is equal to 1. It is an extremely important limit. It comes up all of the time. In calculus, you need to know how to take derivatives. You need to know limits. This is a limit that when you look at it, you might be like, I don't know what it is. Now you know, and you got to commit it to memory. The more common way in which it is written is this. The limit as theta goes to 0 of sine of theta over theta is equal to 1. It also works if you were to flip it upside down. Suppose you said the limit as x goes to 0 of x over sine of x, that's also equal to 1. Are you okay with that? Then let's do the second limit. The second limit is easy. This I could do on my own. The limit as h goes to 0 of the cosine of h minus 1 over h. Where did I even come up with that thing? From the top, right? That's the red thing I put in the box up there. Well, we don't know how to do math, so we're gonna do Spanish instead. Very good. We're gonna multiply by the conjugate. I used that, so yesterday was my first day I taught that in college algebra. We talked about multiplying by the conjugate. They thought that was really, really funny. I enjoy that day every year. Okay, so we got the limit as h goes to 0 of what's cosine of h minus 1 times cosine of h plus 1? Cosine squared of h minus 1 over h times cosine of h plus 1. Now, Chris said something that was almost genius, but he left a little bit off. Yeah, he said that cosine squared minus 1 was sine squared. That's not true. It's negative sine squared. Do you remember that? Sine squared plus cosine squared is 1. And the capital of America is Washington, D.C. These are two things you have to know, okay? So sine squared of x plus cosine squared of x is 1. Everybody knows that, right? You remember from last year. Your teacher wasn't that bad, right? So if you were to subtract the 1 over and subtract the cosine squared over, or the sine squared over, you get cosine squared minus 1 is negative sine squared. Everybody agree? Okay, great. So we have the limit. You're almost done. As h goes to 0 of negative sine squared of h over h times cosine of h plus 1. Well, we're pretty close. I'm just going to write this as two fractions. We have the limit as h goes to 0 of sine of h over h times negative sine of h over cosine of h plus 1. All I did was separate the fraction into two parts. Everybody agree that I maintained equivalence there? Well, what is this limit? That's 1 times, let's plug in 0. What's the sign of 0? 0 over, what's the cosine of 0? 1 plus 1 is 2. What's 0 over 2? Times 1. So what is this limit as a whole? 0. So that's the other limit we know. The limit as h approaches 0 of cosine of h minus 1 over h is equal to 0. It's another extremely important limit that we have to recognize and use within calculus. So I could go back up to my box here, and what can I put? I could put this 0 here. So everybody look at what you've got. What is sine of x times 0? That goes away. What is cosine of x times 1? Cosine of x. So what did you just show? The derivative of sine of x is equal to cosine of x. This is not sine times h, it's the sine of h. So just like you couldn't take the square root of x over x and just cancel off the x's and leave a square root, same thing here. You can't just cancel off the h's, okay? So here you have it, folks. What's the derivative of sine? Cosine. From there, we can prove all the others. What do you think the derivative of cosine is? It's negative sine. But it's a way for us to kind of get moving with it. Now, I won't use this proof again for anything, but it is pretty impressive, isn't it? Anna. Hi, Anna. We hope you're having fun. It's a riveting day right now. I mean, the sandwich theorem, it was awesome, made everybody hungry. And furthermore, you now know that the derivative of sine is cosine. That's ridiculous, though, how long that takes, isn't it? Can you appreciate this? This is all I ask you to try to appreciate right now. We got to this part right here pretty quickly, didn't we? But whoever thought of the drawing and setting up the 3 areas, who thinks of that? Okay, you say it as though there are a bunch of idiots, like, who sits around and does math all day? That is stinking impressive. Like, whoever thought to set that up to use that comparison so that sine of h over h would just come up in the middle of everything, oh my gosh, boom. And then to say, oh, I've got the sandwich theorem that draws them together, absolutely amazing. I am totally in great humility when I see that. I'm like, I am not worthy. I could not do it. That is way more impressive than I am. Rowan. Whoa, 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 whoa. Time out. Time out. So you brought up a couple good points. Number one, math does not rest on studies. You ever hear anybody say, well, the study shows that? Anybody ever say that to you in a class or on the news or something? Do you know that 50% of studies done in the physical sciences are later proven to be false? If it's that case in the physical sciences, just think of what it is in the social sciences, like education, psychology, and everywhere else. Math does not rest on studies. Math rests on this: proof. This is proof. Somebody could put together and say, we think that the derivative of sine is cosine. We have some evidence to lead us to believe that, but we don't have proof. Mathematicians say not satisfactory. You need clear proof. And that is where math is elite above every other subject, without a doubt. Will you ever use this in real life? No. But I'll go back to what I said before. You go to grad school, you take the GMAT, the LSAT. Who are the people that perform highest on those tests? People with what kind of degree? Math degree. Doesn't matter if you're going into being a lawyer, doctor, or anything. Kaylee, you play volleyball. You ever do a wall sit? You guys ever, like, during a game, is that like part of your game plan to go up to the wall and like sit for a while? Do you do that during a game? Why do you do it in practice? Makes you stronger. You ever do push-ups? Do you like is that part of your play? Like they serve the ball, you're like, oh, I got a quick 2 push-up, and then go up and return the ball. Why do you do push-ups? Make you stronger. So why do we do some of these things in mathematics? It makes our brain stronger. Big time. Push-ups for your brain. Yeah. No stupid questions. We just did. Yes, exactly. It changes depending on the situation. No, I'm not. You guys, you know this. You know this. No, you know this. This is not complicated. If you plug in 0 for x for any of these, what do you get? No, you get 0 over 0. But what is it? What is this actually equal to? 1. What's this actually equal to? But they were initially all 0 over 0. There's ways in which discontinuities can become removed, and we figure out that 0 over 0 can take on all sorts of different values. All sorts of different values. And the way of discovering that, uncovering that, that is part of, that's what the word calculus means. The ability to calculate the infinitely small and the infinitely large, which we have not done yet. Ooh, wow. Okay. All right. I'm recording. This is all for Anna. Anna, go take a break.